Hey, g'day guys. What we're going to do is we're going to have a look at finding the total surface area of this concrete pipe. Okay, so you can imagine those concrete pipes. So they've got a smooth surface on the outside and they're hollow through the middle, the whole way to the end. These questions are pretty tricky. There's quite a bit you need to do and you need to think about the surfaces. So let's just talk about the surfaces that there's going to be before we do any calculations. So when we look at this end, this right-hand side end or right face, okay, if we were looking at that in 2 dimensions, we would have a large circle with a small circle out, and we'd just be calculating this area here. Okay, so we're just calculating the ring, if you like. All right. Then if we look at the outside, we've got a whole curved surface that goes around the cylinder, so that opens out, okay? So we've got a big curved surface, okay? And the radius of that big curved surface is half of this diameter. Now this diameter is 2.6, okay? So, sorry, I'm just going to redraw that rectangle slightly differently. I'm going to imagine that I've opened it out, but it's quite long here. So I've got a radius is equal to 1.3, okay, and we know that this bit here will be 2 pi r, and then the height is just that distance from end to end, which is equal to 8.5. So we've got the top end, the bottom end, and the outside end. But there's one more face we have to think about. Because we're talking about surface area, we're talking about all the areas we could touch, I guess, if you like. So there's another surface, and it's the inside part of the cylinder, okay? Now, what you can do with that is you can think about it. If I was to get inside the tube and I was to touch all of it, okay, it's just like another curved surface of a cylinder, okay? So it's going to be if I opened it up, I would open it up again like this. Okay, and this section would be the 2 pi r. That's the bit here that I've opened. Okay, now the radius of that is equal to 1.2 meters. Okay, so it's only a little bit smaller than the other radius. And the height is equal to that 8.5. So they're the surfaces that are different. I'll have one of these, I'll have one of these, but this surface, I will have one on the top end and one on the bottom end. So I'm going to have 2 of that. All right. So before you even start, if at least you can identify the surfaces you need to work with, it's going to make things a lot easier. Okay. So let's start with this ring. Okay. I might work over here. So the area of the ring is going to be the area of the large circle, take away the area of the small circle. Okay? So an area is pi r squared. And just because we've got 2 circles, I'm going to use a capital R for the big one and a little, I'm making mistakes all over the place, and a small r for the little one. Okay, so I'm taking that big circle and I'm removing the little circle from it. So I've got pi. The radius of the big circle was half the diameter, 1.3. And then the small one, the radius of the small one is 1.2. I'll grab my calculator to figure that out. And I get 0.785 square meters. Now I'm going to find the area of the large rectangle. which is 2 pi RH. So that's 2 times pi times 1.3 times height, 8.5. 2 times pi times 1.3 times 8.5, and I get 69.429 for 3 decimal places, square meters. And the area of the smaller curved surface is equal to 2 pi r. 2 times pi. This time my radius is 1.2. My height is 8.5. 2 times pi times 1.2 times 8.5. And we get 64.088 square metres. Now, nearly there. I need to find the total surface area. So the total surface area was equal to 2 lots of the ring plus 1 big curved surface plus 1 little curved surface. So 2 lots of 0.785 plus 69.429 plus 64.088. Which is 133.67, rounded to 2 decimal places, square metres. So, the total surface area of this concrete pipe is 133.67 square metres.